Hey guys, let's talk about the last quiz we took and make sure we're all on the same page as what the real answers were. So, the number one, list the numbered structure, label the numbered structures in this anatomical diagram of the digestive tract. You should have noticed that number one is the oral cavity. Mouth was okay. Okay, number two is the salivary gland. There's actually some people said, well, wait, I thought these are the salivary glands. There's actually three, but we are pointing specifically to this one. So this is the salivary gland, which produces salivary amylase. You can't see this. Okay, number three is the shared space between the digestive and breathing or respiratory systems. So that is the pharynx. Okay, the pharynx, then, assuming the epiglottis is closed, this is the epiglottis. If the epiglottis is closed, whatever's coming down is going to be diverted to the trachea. But in this case, if we're talking the digestive system, this is the esophagus. Esophagus. The esophagus then goes to the stomach. The number six is not directly connected to the stomach. Number six is the liver. It's our big organ here. It goes a little bit behind it too. Number seven is pointing at the gallbladder, which creates, the liver creates bile, the gallbladder stores it, and then empties it into the small intestine. Number eight, this pointy looking guy, that is the pancreas. The pancreas does a lot of things, but specifically in the digestive system, the pancreas creates pancreatic amylase, which gets dumped into the small intestine to break down carbohydrates. That's number eight. Number nine is the small intestine. Remember, it's called the small intestine because it has a small diameter, but it is the longer of the two intestines. Okay, so it has the most surface area. Number 10 is the large intestine, or the colon. Number 11 is the rectum. If you called it the anus, technically this is the anus, but if you said rectum, this is the rectum, which stores feces. If you said anus, that was fine too. And then number 12, not shown, the blood vessel that carries nutrients from 9 to 6, so from the small intestine to the liver, is the hepatic portal vein. Hepatic portal vein. So it's the vein system, which means it's ultimately moving towards the heart. But it's a vein system that moves nutrients from the digestive system to the liver to be processed and then sent out. Okay, that was digestion. Well, some digestion. Let's talk some more. What's the difference between mechanical and chemical digestion? Mechanical digestion is a physical breakdown. Physical breakdown. Hello. Of food. And this can happen with the teeth in oral cavity. You could, no one really did, but you could have also said in humans it happens with hands, because we also use our hands to break bread, to like manipulate tools to break down, do physical breakdown of food. The chemical digestion is any molecular breakdown. Molecular breakdown of food, and we have a lot of examples of this. This is a much more specific thing, so we have a lot of different examples. So this is done with a lot of different enzymes. Okay, so for example, we have salivary amylase, which is a enzyme that breaks down carbs in the mouth. Down carbs in oral cavity. It's in our spit, in our saliva. We have salivary amylase. We have pancreatic amylase, which is the same thing, but it's released by the pancreas. It's made in pancreas. Pancreas, released in the small intestine. Intestine. We have proteases. Okay, so proteases break down proteins. And they are made in the stomach, made in the wall of stomach, specifically those goblet cells of stomach. And then they're released into the stomach. We have, so that's carbs, proteins, lipids are broken down by bile. Break down lipids or fats. And bile is made in the liver, stored in the gallbladder, and released into the small intestine. Into small intestine. Okay, and then finally, the only other example we talked about were gastric acids, which is just very, very strong hydrochloric acid, so HCl, with it's like 1 molar, and it's made it's made again in stomach cells, and it's released into the stomach. Into stomach. All right, cool. Let's talk about the respiratory system. So if you're an oxygen molecule, how do you go from the atmosphere into the bloodstream, specifically in a human? Okay, so let's actually use all of these things. So the very first thing that has to happen is the diaphragm contracts, creating negative energy, or sorry, not energy. That's ridiculous. Creating a negative pressure or a vacuum. Hello. Why can't I spell today, you guys? Which pulls air into oral cavity if the mouth is open, or the nasal cavity if the mouth is closed. Okay, so you think you're breathing in on purpose, like you're drawing. You think when you take a deep breath, you think you're like pushing air into your stomach, but what you're actually doing is just allowing air to come into your stomach when your diaphragm contracts. Okay, so we've got the diaphragm, the oral cavity, the nasal cavity. So the next thing that happens is air moves into the pharynx, which is that shared space between the respiratory and digestive system. Okay, if the epiglottis is closed, so the epiglottis is a flap. So if the epiglottis covers the esophagus, then air moves into the trachea. Moves into trachea. Okay, so there's esophagus is in our list, but air is going to move into the trachea, first passing over the larynx, which is the voice box. Okay, cool. So the trachea splits into the two bronchi, so the left and right bronchus, okay, which enter the lungs. Enter lung tissue. So the bronchi continue to split. Bronchi continue to split into bronchioles, smaller and smaller bronchioles. They're just smaller and smaller tubes. Remember, the bigger the tube, the more volume you can get through it. So the oral cavity is the thing you breathe through. You breathe through your mouth when you're working out really hard because it's hard to breathe in a large volume of air through your nasal cavity. But if you want to have absorption happen, you want a lot of surface area, so a very small volume. So the really tiny tubes are all about getting to where there's a lot of surface area. So the bronchi continue to split into the bronchioles, and at the end of each bronchiole, there is an alveolar duct. Oh my goodness, you guys. Alveolar duct that opens into an alveolus. Into the sac-like alveoli. Alveolus, alveolar duct. The alveolus is where gas exchange actually happens, and if you say plural, the alveoli are covered by the pulmonary capillaries, allowing gas exchange, which allow gas exchange. Boom. So you only had to use how many? 8 of these, but this is all of them. This is the complete idea. A lot of people think that air goes through the diaphragm, and that's not true. The diaphragm is actually not, it's a muscle, so it's not actually connected directly to the trachea and everything. The diaphragm is a muscle underneath the lungs. Its contraction causes the lungs to fill up with air. The relaxation of the diaphragm lets the lungs relax. It lets the lungs the weight of the rib cage will then push down on the lungs and allow them to deflate, no matter how you're sitting. We also have some muscles in there doing something, which you don't have to worry about. Okay, let's talk surface area. So surface area plays an important role in all 3 of the systems we studied so far, and technically it does in all of our body systems. So explain why this is so important. So the more surface area you have, the more area of absorption you have. More surface area means you have more area for absorption. For absorption, okay? You could also say the more area for diffusion. Okay, if we're talking about the, so this doesn't include, this quiz we did before we did the reproductive system, but in the reproductive system, the surface area is incredibly important in the seminiferous tubules because it allows for a lot of area for cells to divide, and so it's a lot of area for cell division. So it's still just a lot of area for something to happen. Okay, but in our specific systems, we talked about we talked about this in the digestive system. And people actually had some really good thoughts that we didn't discuss. So in the digestive system, mechanical digestion opens up more surface area for enzymes to work on. So that is a great example for enzymes to work. That's a fabulous example. So it's not absorption or diffusion, but it's allowing something to area for something to happen. We also talked about how the small intestine is so long and thin. Intestine has lots of surface area. Hello, I'm writing in a weird angle, you guys. Has lots of surface area for nutrient absorption. Absorption, okay? In the respiratory system, this is specifically looking at the alveoli. Each alveolus is very small, but there are millions. But there are millions of them. So this is like if you have a whole bunch of grapes, okay, and they're all just hanging out with each, whatever, and then you peel every single grape and put the skin of the grapes all next to each other, you're going to get a huge surface area, okay? And this means there is a lot of area for gas exchange. Now, none of this stuff matters, so it doesn't matter if we have nutrient absorption or gas exchange if we don't have in the cardiovascular system the capillaries. So capillaries are basically one cell thick blood vessels, which means the cells that are going through this blood vessel have to go very slowly, and they're also very close to a membrane so they can do diffusion. Okay, so diffusion or absorption of nutrients, if you're dropping off, well, not necessarily, nutrients, wastes, and gases happen. Okay, so every cell in your body is about one cell away at most from a capillary bed. So it means every cell in your body has a very quick source of nutrients and gases and has a place to dump its waste so it doesn't kind of sit in it. Okay, hopefully this made sense, and happy studying.